Good morning, welcome back, and thank you for being here again. Yesterday we kind of went through OData starting at a very high level, fairly quickly getting down into some of the specific URL patterns, format, and so forth. And again, my intention there wasn't to have you guys leave experts on OData, but to have you guys kind of understand a little bit more how OData works, what it is capable of, what its limitations are, and so forth. Along the similar lines today, we're going to talk about implementing OData, and then we're going to talk about testing OData. And again, my goal isn't that you leave here and write 100 OData services, although if you are so inclined, I understand it's very fun to do, and I won't stop you from doing that. But my intention is really to, again, give you an idea of what's involved with implementing an OData service, what types of things to consider, and so forth. So we're going to start off when we talk about implementing an OData service with really three things, three decisions that you need to make up front. The first is, what level of conformance to the OData specification are you trying to target? And this is actually one of the most important decisions that you need to make early on. As I said yesterday, the OData specification is a large specification. It's actually fairly comprehensive. You can do a lot with OData. But it's not expected that every service implement the entire specification. There's different formats that you can implement. There's extended query functionality you can implement. We talked yesterday about deltas and async. A lot of the deltas and async and so forth are fairly advanced technologies, and most of your services probably won't implement them, at least not initially. You don't need to implement all of the specification in order to be a compliant OData service. The OData protocol actually defines 3 levels of conformance, which we'll talk about in just a second. But really, OData is intended to define conventions for exposing the functionality that you want to expose out of your service. So if you were writing your own custom service because you had some interesting data, rather than kind of making up URL patterns, making up formats, and so forth, if you follow the OData protocol for how those formats and URLs and so forth look, you'll get advantages right away from the ecosystem. But it's not intended to say, oh, now I have to, because I'm following OData, I have to do all this extra work. In fact, it should be less work because there's libraries you can leverage, there's documentation you can leverage, there's test tools, and so forth. The next decision you're going to need to make, and actually you may not have a choice here, is what platform are you implementing on. So we do have OData libraries for Java and .NET, and some PHP libraries as well. Again, you don't need libraries. All you need is an HTTP stack, and you can be off and running. But there are libraries that do a lot of the serialization and deserialization and make things easier for you. And that brings me to the final point. Look for, on the platform you are, common libraries that you may want to use. And on Java and on .NET, we have kind of 2 levels of libraries. The lowest level of library just does serialization and deserialization of OData compatible payloads, and also parsing of URLs. So it takes the URL and parses it into a query tree. And then we have more advanced frameworks that actually plug in a lot of the other logic for you. And we'll see an example of one of those in a little bit. So I mentioned that OData defines levels of conformance. And you don't have to conform to any of these, but if you do, then with each of these levels, it sort of implies a certain level of interoperability with other tools. So if you're just trying to build a service and a client to consume that service, you may not care about conformance right now. You might care about it a little bit more later, but it just kind of gives you targets for things to look at. The lowest level of conformance is appropriately named the minimal conformance level. And the scenario around that is really kind of data publishing. You have some data, it may not be backed by a database or even query functionality, but it's got interesting data, and you'd like to expose that so that generic tools like Excel or Tableau or something else could at least import that data and look at that data through a common format. So that's what we call the data publishing format. You need to support the JSON format in order to meet that level of conformance. You need to publish your metadata, as we saw yesterday, the dollar metadata endpoint. That can be a static endpoint that you just write that XML and post that file on your service. That allows generic tools to understand the shape of your data. And then you may have limited queryability or even no queryability. You may just be posting files. But at least by following the format and publishing your metadata, you get some entry level of interoperability with clients. For the best interoperability, well, best interoperability would be at advanced, but at intermediate conformance level, that's really sort of the level that we'd like to target for interoperability, for working with tools like Tableaus and Excels and so forth. That has basic query functionality and basic service features. I won't go into what all of those are, but they're things like basic filter. You don't have to support filter on all properties. You don't have to support all of the different built-in functions, but some basic level of functionality will help make sure that tools like Excel, when they're consuming your data, can pull down just the right size of data to address the gentleman's questions yesterday. What if I have very large sets of data? So really this level is about making sure that the client can get the subsets of data that they're particularly interested in. And then the advanced conformance level is kind of everything else. And there's the additional functionality. There's things like async and aggregation and deltas and so forth, which are all really interesting functionalities. And they may be interesting in certain scenarios. But if that's not the functionality you're trying to expose by your service, there's nothing that would push you to feel like you needed to do that. Any service may be read-only or read-write. That doesn't affect the conformance level. If you are a read-write service, there are certain rules about what you must do as a read-write service to be able to comply. Things like exposing your edit links. So that's sort of an overview of the different levels of functionality you might consider. And those are documented in the OData v4 specification. All right, so you actually have quite a number of different ways that you can expose a data source. You may not have to write any code at all. We've got things like Windows Azure Data Market. RightStarDB has a nice implementation of an OData service over a Sparkle endpoint. We've got the MySQL OData direct service and the OData connector. These are different things that basically you point at a database and you say go. So if you've got your data in certain types of backends, you might be able to leverage those backends as they are without doing a lot of extra work. In .NET, there's 3 levels of services that you can implement. The first is using OData library. And if you've got an HTTP stack already, and you're handling HTTP, and you're handling the requests, and you just want help with serializing and deserializing, and with parsing the URL, this library is your ticket. If you're kind of starting more bare bones, you can use the ASP.NET Web API, and we'll have a demo of what that looks like in a little bit. WCF Data Services is a component that we used for building OData services for V1 through V3. We're actually moving away from that and more towards the Web API model. And the reason for doing that is because the WCF Data Services stack was a very monolithic stack. And it did a lot of functionality for you, but if you wanted to add custom logic, it was very difficult or impossible to do, where the Web API stack is much better factored for doing that. In Java, there are actually 2 OData projects for Java. One is called OData for J, and this was the first Java product. But there's not been a lot of work done on this project in a while. The second is Olingo, which is a newer OData project. It's factored a little bit differently, and there's work going on to move Olingo to OData version 4, whereas OData for J, I think, is still version 2 of OData. So you've got different options here. These are all open source. And in PHP, there's a PHP provider. These are just some of the ones that we know about. People often ask me, who's implementing OData? And I can't give you the exhaustive list because I learn about new people every day, people who are just like, oh, yeah, we use OData for X, Y, Z. Same thing with the libraries. If you go to a website called odata.org, There's actually a list of different libraries and a list of different producers and consumers and services that you can go to there. There's some sample services, pointers to all of the specifications and so forth. And we're constantly getting people saying, can I add my provider? Can I add my consumer? Can I add my libraries? All right, so let's jump into a walkthrough of what it would look like to build an OData service using Web API. And there's basically 3 things that you have to do, and Web API handles the rest. The first thing you need to do is you need to describe the model that you want Web API to expose for you. Describe the classes that you want to expose that describe the resources of your service. And there's 2 ways to do that. You can do that in a very manual model building operation, or you can use defined types in your system in order to just, Web API will reflect over those and expose the metadata on those. You then need to implement the routing. So routing basically is a way, how many people have built a Web API application before? Okay. Web API is a framework for building web applications, and it's based on this idea of routes. So for each route, for each URL path, you implement a method that returns the information for that path. And then it takes the data that you return and it serializes it and deserializes it and has a way to call your particular method by parsing the path. So we'll see what that looks like. And finally, Web API has this concept of a controller, and a controller is your code that handles a particular request. And controllers can have multiple different methods for multiple different types of requests to a particular segment. It'll all make sense when we go through it. So basically, you write the code that describes the model, describes how to get to the methods that you want called for that model, and returns the actual data. So it goes and talks to the database, or makes other web service API calls, or accesses a local file, or does whatever else it needs to do to return the data. And then Web API exposes that as a service. It exposes the dollar metadata and service document endpoints. It parses the URL and routes to your methods based on attribute routing or convention routing. We'll talk about what those are. It deserializes the payloads. If someone's giving you a customer that they want inserted into the service, it will deserialize the JSON on the wire. It applies query options like filter, sort, and expand to the query that you return it. And it takes care of formatting the results on the way out. So it's a pretty fair trade-off. All right, so let's see what that looks like, and hopefully all of this will make a little bit more sense. So I'm going to start off Visual Studio, which you can't see. Now you can. Okay, start up Visual Studio. I'm going to create a new project. No, I can't see it. This is so confusing. And I'm going to make it a web application, and I'll call it Plugfest. I'm going to create it as a Web API application. And that's going to install a lot of default files and stuff for me. So the first thing I'm going to do is I'm going to create a model. The model is the actual access to the data that I want to expose to this service. And I can do that in any one of a number of different ways. I can have a statically defined model where it's just data that I produce locally. It can look it up from a local file. It can call other web services in order to get the data. In this case, I'm going to create an ADO.NET entity data model. I've never found a reason to change the default name from Model 1. And I'm going to get data for this data model out of the Northwind database. How many people are familiar with the Northwind database? It's been the sample database for SQL Server for 20 years. Maybe not quite. It replaced pubs, I guess. All right, so it's going to ask me which tables I want to expose, and I'm going to expose customers and orders. So it's going to go off and it's going to query the tables, it's going to get the metadata for those tables, and it's going to create an entity model for those. So it's identified customers and orders, the properties for those, and it's detected the foreign key, so it's actually created a relationship between those. So now I have a model. The next thing I want to do is I want to add a reference to Web API. And I'm using a pre-release, but there are release versions of this. This pre-release version will be released at the end of this month. It's just got some more functionality in it. And I'm looking for web. Sorry. Microsoft ASP.NET. There it was. And I don't know if you guys have used just a second. No, that's not the one. There it is. I don't know if you guys have used Visual Studio. How many people use Visual Studio? And how many people have used Nugget? Yeah, it's amazing. No more digging around for where your libraries are and trying to figure out all the dependencies and so forth. It kind of does all that for you, but you have to know what you're looking for. Okay. So I've installed the ASP.NET Web API 2.2 for OData NuGet package. And once I've installed that, I can go off and the first thing I want to do is I want to go into my Web API config, and this is where the routes are defined. So this is how ASP.NET Web API knows how to take an incoming request and call the appropriate method for that request. Oh, you know what? I have trouble seeing it too. Better? Okay. So the first thing that I'm going to do here is I'm going to implement a method to build the model, the resources that are exposed by my service. So I'm going to make a public static. Oh. Why does it not want me to type? Oh, sorry. I'm going to do it here. I'm going to resolve this reference. Okay. So the model is going to use the OData model builder. Let me resolve those references. Oh. There it is too. shoot, I didn't want to do that. Sorry, I'm not using a very good keyboard here. Let me just do this. All right. So the convention model builder is a built-in class that allows me to build entity data model exposed by my OData service just out of the classes. So I'm going to start with model.entitySet of customers. So this says, create me an entity set named customers of the customer data type. Customer being one of the types that was generated when I created the model. And then I'm going to do the same thing for order. And then I'm going to return the model. So that just is going to, again, reflect on the customer type and the order type, build me a OData model that has two entity sets, one named customers and one named orders. In fact, I should, if the gods are with me, be able to run it. Oh. There we go. Oh. Having trouble bouncing between machines here. Sorry about that. It's loading on the wrong machine. Okay, we'll hold up. Oh, so I forgot. I created the route, but now I created the model. Now I have to actually expose the route for that model, and so I do that with config. Oops. I wish there was an option there to say stop debugging. Config dot map OData service route. Can't type today. And I give the route a name, a path, and a model. Resolve that reference. That should do it. There we go. So that's actually going to build my metadata endpoint for me and my service document. So the next thing I need to do is actually implement my controllers. The controller is the code that handles the requests for each of the entity sets, for the customer's entity set and the order's entity set. So I'm going to add a controller. And this is going to be my customer's controller. And I'm going to derive from the OData OData controller. Solve that reference. And this is where I'm going to put the code for handling requests to the customer's entity set. So the first thing I'm going to do is I'm going to use an OData route prefix attribute that says customers and resolve that reference. Come on. So that's going to say that requests that come in to the path customers get handled by this controller. And I'm going to add a enable query attribute, which says that the things returned by this, actually, I'm not going to add it here. Sorry. As I was describing what that did, I'm like, that doesn't make sense there. All right. So now I'm going to implement methods here. The first method I'm going to implement is a method for get customers. And it's going to be the method that actually returns all the customers. And so I'm going to use my let me just add that now. My Northwind entities context. And it's just going to return OK with the context.customers. So context.customers is going to return, geez, yesterday I couldn't speak, today I can't type. Context.customers is going to return an iQueryable over the customers in my SQL database, and then that's just going to be returned from my method. Now, I want to do two more things. I want to annotate this as an OData route, meaning when Web API goes to route things, it should look for this method. And this is where I put my enable query to say the result of this is a queryable. Oh, sorry. The result of this is a queryable, and queryables are composable. So I'm just returning all of the customers, and Web API, because of this, is going to take any filters or any sorts or any expands or anything else, selects that are present in the URL, and it's going to automatically append them to my queryable. So I don't have to do any URL parsing. I don't have to do any additional application of those. Web API does that for me. All right. So that'll return my set of customers. The next thing I want to do is return an individual customer. And I'll explain what this is in a minute. Okay. Whoops. Okay, so what this route says is appended to the customer prefix an open paren and close paren with an ID in it is going to be a parameter, is A, going to route to this method, and B, I'm going to now extract the ID from that, and I can use it in my function to look up the particular customer. So I'm going to, again, enable query over this, and then implement my method public I HTTP action result, get customer, and I can do int ID, actually string ID. And this OData attribute is both going to route to this method and extract the ID and pass it to me as a parameter. And so then, if I can find my mouse, I can implement a simple method, return OK, I'm very optimistic. I should do more error checking in here, but I'm going to return OK, everything's good. And I'm going to return context.customers.where for my customer.customer ID is ID. That's actually going to be a single result, so I'm going to, there's a nice constructor I can use, single result, create customer. What this does is the query that I wrote here will return a customer with a particular ID. This single result.create, so if I just return that customer, well, this query returns a collection of customers that happens to have one customer in it. But it's expecting to get back a single customer, not a collection of customers that has one. If I did a dot first or default, which is how I'd normally get a particular instance of a customer, now I can't compose a query on top of that. Or if I do, it'll just be in memory. So single result says, here's a single result that represents a customer, but it still isn't iQueryable, so you can still query through it if I want to expand to get the orders for that customer and so forth. I'm missing a paren, and now that should be happy. OK. So I've implemented a method to get all of my customers and a method to get an individual customer by ID. I can also implement methods to add a customer. So I'm going to do OData route. And this is going to be a action result for post customer. And it's actually going to take a customer. And I'm going to do my context dot customers dot add customer, and then I'm going to do context dot save changes. So that's just going to add the customer and then save that to the database. I can also delete my customer. And I can do a HTTP action delete customer. Now in this case, it's going to take an ID. So in my route, I need to do the same thing I did before. And then I can do string ID. And in this case, I'm going to do context.customers.where c.customer name equals ID. In this case, I will do a first or default, which means get me the first of the customers returned by that query. And so I'm going to say var cus equals that. Now, if that is not null, then I'm going to go to context.customers. And I'm going to remove that customer. And then, again, I'm going to return OK. There's two more methods I might want to implement. The first is a modification method that will modify the customer. So let me give myself a little bit more room for that. So I'm going to public my HTTP action result, put customer. And I'm going to, again, take the ID. And I'm going to do an OData route for this. And I'm also going to do yeah, I'll just do that for now. And so for my put, I'm first going to do context dot customers dot. Actually, put is going to take both the ID and the customer. And again, Web API will deserialize the payload and materialize an instance of a customer and pass it to my method for me, so I don't have to worry about any of that formatting. So I'm going to do customers dot attach. And then I'm going to do context dot entry of customer dot state. So what this is going to do is it's going to take the customer that has been deserialized off the wire, it's going to attach it to the customer's entity set, and then this is going to mark it as modified so that then I can turn around and do a context.save changes. What doesn't it like about that? Oh. And again, I'm going to return OK. And actually, I'm going to return the customer. And again, I don't need to serialize it. All I do is return the customer, and Web API takes care of the serialization of it for me. OK, there's one final thing I may want to do in this method, which is customers are related to orders. So I might want to implement the logic for navigating from a customer to that customer's orders. And so the way I do that is I define an OData route that is the ID followed by orders. And then I'm going to return OK. Context dot customers dot where given the customer ID. Why is this not context.customer? There it is. This is ID, and I'm going to do a select many. C.orders. And again, that's going to return it as an iQueryable, so I want to be able to append additional queries to that, so I do that with the enable query attribute. So one of my methods didn't return a value. Oh. And I'm going to return. Okay. So that's my methods for the customer entity set. So I've got a method that returns all the customers, returns a particular customer, adds a customer, deletes a customer, modifies a customer, or gets the orders related for a customer. I could do the same thing for orders and write the same logic. The nice thing about Web API is it gives me complete control. So these are currently calling into the entity framework. They could be calling web methods. I could be modifying the results. If I wanted to secure my service and I had some row IDs, I could do additional filters here to filter only those records that a particular user had access to. So I have complete control, but as you saw, there's quite a bit of typing that I need to do in order to implement all of that. So we have a solution for that, if I can get to it, which is something called scaffolding. And scaffolding basically is a way that I can generate that code automatically. So if I come in here and I go to my controller and I select add new scaffolding item for, in this case, I'm going to use Web API 2 with the entity framework. Now I can name this, so orders controller. And my model class is order. And it figures out that there's a context in my project, and it automatically creates that, or pulls that up for me. So I can add that, and it'll go off, and it'll write the code, and it'll actually write code with error handling, which is probably something I should have done to start with. So now it's implemented basically those same methods. It's created the Northwind entities. It's created the method that returns a single order, updates orders, and so forth. Now we'll see if I can run this. Okay. Hello. All right. So here's my service. And if I go to OData, oops. Did I call it OData or Northwind here? Hold on a second. OData route. Popped up on the right window that time. There we go. Now I can go to the service route, and it shows me. Oh, yep. Sorry. Let me do this actually real quick. Yes, I know. Actually, that's not going to make it any bigger. All right, I'm not a Chrome user, but JSON displays better in Chrome. How do I make this bigger? Anyone? Ah, here we go. All right. So now if I go OData, There are my customers and my orders. If I do OData / $metadata, then I can get the $metadata endpoint. If I do customers, I can see my customers. I can get an individual customer. I can get orders for an individual customer. So I have a working service. So there was a fair amount of code that I needed to write in the first place to get it working. A lot of that code was then automated through scaffolding to make it kind of all work by itself. Now, I didn't actually ask before my session, but are you guys under NDA or is this not under NDA? All right. In that case, I still didn't ask. Okay, where is my presentation? What? Okay. So without announcing any new products, I should turn off the camera. Imagine there was a way that rather than having to write the code for those individual controllers for the individual entity sets, or even have to have the generated, which is fairly static and means that if your model changes, you have to go back and regenerate those classes, if you had more of a declarative way to build your OData service. So instead of implementing a controller for each of your different entity sets with a method for each of the put, post, delete, get operations, you could implement one controller that would take your model and expose the expose the service for it, and then give you the way that you could sort of declaratively add business logic to that, to hide sets that you didn't want exposed. So it's a subtractive model rather than an additive model like we saw before where we added that on. This would be a system, if it existed, that would build on Web API. It would give you very customizability in reusing your domain logic and overriding just the logic that you wanted to have exception logic rather than writing all of the logic. And it would be a much faster way to do it. And I would give you a demo of it, but we're running out of time. So that's building an OData service. What does that get you? Why do you want to build an OData service? Well, because there's a lot of ways to consume an OData service. So again, from JavaScript, from Java, from .NET, Ruby, PHP, Drupal, there are a lot of different libraries for people to write applications. There are a lot of different devices that we support OData on. So there's client libraries for all these different devices. And there are applications like Excel that allow you to build a query and import data into your spreadsheet. So I'll show an example of that real quickly. And for this example, if I can get Chrome to come up. Where's my mouse? I'm going to go to odata.org. So odata.org is a website that has a bunch of different information about OData. It has the documentation for the various different versions. It has blogs, has lists of libraries for different platforms for building services and clients. information about the ecosystem of producers and consumers. And it also has some sample services. So I'm going to go to this sample service, and this is the one I'm going to consume in Excel. If I can get Excel to get to the right screen. I can. What am I doing? Okay, so Excel has the data ribbon, and I can do from other sources from an OData feed, and I can read it directly into the spreadsheet. That's going to read all the data into the spreadsheet. More interestingly, I can use Power Query, which will allow me to build a query over that OData data and bring back the information that I'm interested in. So I can come in here and go to the Northwind service. And it'll query that $metadata endpoint, and it'll tell me these are the different services that are exposed by that $metadata endpoint. I can build a query over one of those. Opened in the wrong window. So it built this query over that. I can go through and I can hide columns that I'm not interested in. And I'm not really interested in these or this. Now, my result is a hierarchical result. I have customers, and customers have related orders. What Excel has done is for those nested results, it's told me the orders column is a table, kind of a nested table, and I can go through and expand that. And so for the order, I want to get the order details. And for the order details, which is another table, I want to get the unit price, quantity, and discount. So that's going to go through, and it's going to basically flatten out for each customer the unit price, quantity, and discount for each of their orders. And this is all pushing queries to the SQL Server backend, or to the OData service. The next thing I'm going to do is I'm going to add a column. And it lets me build a nice custom expression for this column. So I'm going to take the unit price, I'm going to multiply it by the quantity, and then I'm going to multiply that by 1 minus the discount. And that's going to give me the total price. So now this Excel is actually doing locally. It's bringing down the individual fields, and then it's calculating that locally. And now I can hide these other columns. Now, Excel's giving me this nice view. Oops. It's not actually bringing all of the data down every time. This is just sort of a sample of the data that I can use to build my query. Once my query is built, I can apply it and close, and it'll bring my data into the spreadsheet. So here's all of the data, and now I can do whatever analysis I want in the database on that data. I'm going to create a Power View. And I'm going to make that a map. And I'm going to hide some of these fields. Actually, I'm going to do it by country. And my total price is going to be summed together. And so now, it's actually going to, wait. count. I'm going to okay. I'm going to add those as size, and so now it's going to go out to that OData service. It's going to bring back the data. It's calculated out the orders, and now it's going to give me a nice graph of who's spending more money from the various different stores. And now I can go back to that Power Query, and I can edit it, and then it'll be all reflected here. So this doesn't do justice to Power Query or Power Chart or anything else that we have, but just shows you the nice integration between, once I go through and implement that OData service, how nicely it integrates with things like Excel. All right, so in summary, we talked yesterday about what OData is. It's open data for the open web. The protocol itself is very open. It is very accessible by consumers because it exposes its data model. It describes what you can do with the service through dollar metadata and through the service document. And that helps increase the productivity. It helps tools like Visual Studio, and I didn't get a chance to do that demo, but Visual Studio has a nice integration where you can just point at it and it'll generate classes, and those same link queries that I was writing to implement an OData service by querying customers and their orders and so forth, you can write that same type syntax against your OData service. Because it's HTTP, it's ubiquitous, it's anywhere. The OData protocol gives you shared semantics, and there's a variety of different implementation options for different platforms, different devices, open source libraries, and so forth. Here are some resources on OData. OData.org is probably the best starting point, and it has links to everything else. The OData Technical Committee page is where there's actually the information for the OASIS standards work. And there's a nice, if you're familiar with OData version 3, there's a nice document, What's New in OData version 4, that talks about a lot of the new changes. So we're right on time, although I know that the next speaker doesn't mind us going a few minutes over. So I know that was kind of a quick run through, and I apologize for some of the technical issues. Again, my intention wasn't that you leave here an expert in implementing OData, but that you kind of understand what's involved with implementing OData and what it gets you from a consumption point of view. Any questions? All right, let's go ahead and take 10 minutes, and then we'll be back and we'll talk a little bit about validating an OData service, and we'll wrap up. Thanks.